Astronomers have created a three-dimensional map of a known gas bubble surrounding our solar system. And they were in for a big surprise. We live in a bubble. That's actually true. Around our solar system, a huge gas pocket spans an area about 1,000 light-years wide. This pocket is called the local hot bubble, or simply the local bubble, and it's believed to have formed around 14.4 million years ago after a series of supernova explosions. About 5 million years ago, our solar system moved into the bubble, and we are currently located inside it, while the bubble itself continues to grow at a rate of 6 kilometers per second. Now, a new map of the bubble has revealed a mysterious interstellar tunnel. A research team at the Max Planck Institute for Extraterrestrial Physics in Germany has compiled a three-dimensional map of the local bubble, as well as several nearby bubbles. The map was created using data from the German-Russian space telescope Rosetta, which stopped collecting data after the war in Ukraine broke out in February 2022. The space telescope is about 1.5 million kilometers from Earth and has been observing the temperature of gases through X-ray measurements. A surprise for the researchers. This isn't the first time the bubble has been mapped, but the new map contains more details that were originally intended to help investigate whether the bubble was created by supernovas. Scientists believe that the force of supernova explosions pushed away materials such as hydrogen and dust, which over time created the pocket. This means that the inside of the bubble contains only about 1/10 of the hydrogen that exists outside the bubble, which is a layer of hot gas and dust. Supernovae created a star factory. The local bubble was gradually inflated by a series of supernova explosions. Since then, the solar system has moved into the bubble, and today we can observe star formation on the surface of the bubble. Supernovae inflated the bubble. The bubble formed 14 million years ago when a giant star exploded as a supernova, blasting gas and dust in all directions. Since then, 14 more supernovae have expanded the bubble, which today spans 1,000 light-years in diameter. With each explosion, more gas and dust accumulated on the surface of the bubble, and over time the dust became dense enough to form new stars. About 5 million years ago, the solar system moved into the bubble. The solar system is now located in the center of the 1,000 light-year wide bubble. Inside the bubble, there is too little material for stars to form, but along the bubble's surface, there are 7 areas where new stars are being born. The large amount of data from the Rosetta telescope confirmed the supernova theory, but the research team was still surprised. What we didn't know was that there is an interstellar tunnel toward the constellation Centaurus, which cuts a hole into the cooler interstellar medium, explains astrophysicist Michael Freiberg in a press release. The exact destination of the tunnel is still unknown, but at first glance it appears to be filled with hot plasma and could be linked to an adjacent pocket, the Loop I Superbubble. The researchers will now further investigate the tunnel to see if there are more tunnels like it. If there are more, it would support a 1974 theory that our galaxy consists of a connected network of hot bubbles and interstellar tunnels. Using data from the Gaia Space Telescope, astronomers have, for the first time, compiled a detailed three-dimensional map of the so-called local bubble. The map not only reveals that Earth is located in the middle of a star-forming bubble, but also how it came into existence. The local bubble was formed by a series of violent supernova explosions that have taken place over the last 14 million years. When the supernovas exploded, shock waves swept together the surrounding gas into a dense shell, forming the surface of the bubble, explains Catherine Zucker, an astronomer at the Harvard-Smithsonian Center for Astrophysics. The bubble spans 1,000 light-years in diameter and functions like a cosmic birthing clinic, constantly changing our night sky. Supernovae inflated the bubble. The local bubble is a void between stars in our local galaxy, the Milky Way's Orion arm, and it was formed about 14 million years ago when a massive star collapsed and then exploded as a supernova. In the Milky Way, about 2 supernovae explode every century, and in a fraction of a second, they release as much energy as the sun does over the course of a million years. Supernovae emit large amounts of gamma radiation, which is created when a certain variant of aluminum decays into magnesium. Astronomers can measure the gamma radiation to register when a star has exploded. This way, they have analyzed that a total of 15 supernovae over the last 14 million years have contributed to the expansion of the bubble and inflated it even more. Each time one of the stars exploded, it ejected all the material in the surrounding area, such as dust and hydrogen. Over time, the supernovae created a pocket in space that forms the bubble's interior. For example, the pocket contains only 1/10 of the hydrogen found outside the bubble. Astronomers have known about the local bubble for 50 years, but it is only now that data from the Gaia telescope and new computer programs clearly show how large the bubble actually is, how it is shaped, and what is happening along its surface. And there's actually a lot happening. Researchers from the Harvard-Smithsonian Center for Astrophysics have studied the distances to the nearest star-forming regions around the Sun, and it turns out that most new stars are located on the bubble's surface. Not only that, but they are also moving away from the Sun at a speed corresponding to the bubble's own expansion rate. The researchers conclude that all the material that supernova explosions have pushed out of the bubble's interior and gradually forced outward has clumped together to form a sort of membrane of hot gas and dust that makes up the surface of the bubble. Here, material has accumulated over time, and it's this material density that is crucial for new stars to form. The higher the material density, the greater the gravitational pull to attract more matter. Along the surface of the bubble, astronomers have recorded 7 such areas where the material is dense enough to act as a star-forming nursery. As the material becomes denser, the temperature increases, eventually forming a protostar. Over time, the heat and pressure become so great that atomic nuclei begin to fuse, releasing large amounts of energy. In other words, the protostar begins to burn through fusion and becomes a true star. How the solar system ended up in the local bubble has been somewhat of a mystery. The universe is constantly expanding, and everything, including our solar system, is in motion. Calculations show that about 5 million years ago, the solar system moved into the bubble, which is growing at more than 6 kilometers per second. The solar system is currently located in the middle of the bubble, and astronomers believe that bubbles must occur frequently in the universe, because if they didn't, it would be statistically unlikely for us to be inside one right now. The researchers believe that these bubbles are common and create many voids that are poor in matter inside galaxies, much like holes in Swiss cheese. Therefore, it is likely that most stars in a galaxy form on the surface of bubbles like the local bubble. The large cosmic explosions of dying stars create a fertile ground for new stars to be born. The researchers will now investigate more bubbles in the Milky Way to find out how they interact when they collide and what role they play in the life and development of galaxies. Our location inside the local bubble may have protected our solar system from harmful radiation over the past thousands of years, explains Catherine Zucker. In the meantime, we can look up at the night sky and enjoy the front row seat to the birth of new stars. We hope you found this information interesting. If you did, please take a few seconds to like and subscribe. It really helps a small channel like ours. Thank you for watching to the end. We wish you a wonderful day.